today we're going to be doing, like taking a fraction of a fraction. It's multiplying fractions by fractions. We did this, Brayden. We did this. I showed you how to multiply fractions by fractions the other day. It might have been last week, or it might have just been the other day, where I had just told you just multiply straight across. But now we're really going to be doing it, where I'm showing you how it works. One of the things is that they're going to be talking about is drawing a rectangular model. Again, not my favorite method, because unless you really truly get it, it can be a little bit confusing. But I'm going to show it to you because in some instances it is necessary. Because when it comes to word problems, you are going to have to like draw out a model to understand the problem. So if I give you a problem like Miss Mason brings some brownies to school, and she made 4 pans. She had 4 pans of brownies. Okay, so she brought 4 pans. All right, you can draw this if you want to. So she had 4 pans. So half of these she left at home. Exactly. So these she brought to school, and these she left at home. So 1/2 of 4 she brought to school. So what would my multiplication sentence look like for that? What would my multiplication sentence look like?
It would be 1/2 times 4.
Mm-hmm. Equals
2. 4 over 2.
So we have 4 over 2 equals 2. So 2 came to school. So since these stayed home, we're not worried about these anymore. So now 2 pans of brownies came to school. Okay? So half of these 2 half of these, one of them she gave to me. I know, right? She's a good friend. She's like, Miss Strickland, I owe you a pan of brownies because you've worked so hard.
How do you want it upside down?
Sideways.
Sideways, but standing straight up like.
Like, Miss Strickland, you're so awesome.
I know.
I can write upside down. I can read upside down.
I know.
So
You're like
1/2 of 2 came to me. Strickland. So what would that multiplication sentence look like? So 1/2 times 2.
This
one
is
is
1.
It's 1. Right. Because it goes across. 1 times 2 is 2. It goes straight across. 1. So Miss Mason gets to keep this one. These 2 stayed at home. Miss Mason gets to keep this one. This one's mine.
I'm gonna see if I can.
She might decide to share these with you. I don't know. She may. I don't know. But these are mine. These are all mine. Okay. So, but because I'm so nice, I may kind of go, well, Miss Catlett, I'm such a sharing individual. I'm going to share my half with you. So, I'm giving my half of 1
I did it. 1/2.
with Miss Catlett. Okay, so 1/2 of 1. Ariana.
1/2 times 1.
1/2 times 1 equals
1/2.
1/2. Right, you 1 and 1/2 is just
1/2.
1/2. Went to Miss Catlett. Because 1 times 1 and then 2 times 1. Right there. But we're not worried about that. We're just splitting up this one. Now, Miss Catlett says, Miss Chapman, I got some brownies that Miss Mason made. I want to split them with you. I know, because I still got my half over here. So we have this half of 1/2. But you know what? I'll probably go over here and I'll eat some of Miss Mason's. Okay, so we have 1/2 of 1/2.
1/2 times 1/2.
1/2 times 1/2. You go straight across and multiply. 1 times 1. 1 times 1. 1. 2 times 2. 4. Look, if I took this line and I brought it down, how big are those pieces? 4. Oh.
It's basically the same thing, multiply.
She might be nice and give me a piece. So, every time you take that piece and you take it by a half, they get smaller. So, I'm multiplying it by 2. If I took my piece of paper, I fold it in half, I have 2 pieces.
Yes.
I take that half, and I fold it in half again. I took that 2, and now I have a half of a half, and I have 4. I take my fourths, I take a half of a fourth, and I have 1/2 of 1/4. 1/2 of 1/4. Multiply across. 1/2 of 1/4. Multiply across. 1, 2, 3, 4, 5, 6, 7, 8. You multiply across. I have my 8, and I multiply across. Oh! So I had my 8, and I put them in half, and I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. I have my 16ths, and I fold them in half. 16 times 2, 1/2 of 16.
32.
Good job.
132.
1/32.
Oh my gosh.
It's not folded very well, but there's 32. So I know. So every time I fold it, I'm taking that denominator and I'm multiplying it by 2. But it only, this right here would only work by 2 because I'm folding it in half.
The denominator is the
We're going to do that today. If Jan has a third, if she has 1/3 of a pan of treats, it's supposed to be Rice Krispie treats, but I don't want to write it. 1/3 of a pan of treats. And she sends 1/4 of the treats to school with her children. What fraction of a pan does she send to school? So this is where Jakaria was asking me, she goes, will you have some where it's not like a half, where there's not going to be a 2 in the denominator? Well, yes, you can have an 1/8, you can have a 1/16, you can have a 1/5. It's not always going to be a half. We just started off simple because a half is easy. So there can be different denominators. You're not always going to have a 1 in the numerator. It can be 5, 6. It's not always going to be really easy small fractions. They are going to get bigger. We start off small. So if we had a pan of brownies or Rice Krispie treats or whatever. Brownies is easy because I like brownies. So if she has 1/3 of the treats, so I'm shading in only 1/3 because that's all that we're dealing with. You see what I did? Only 1/3. So that's what she has. And so I'm going to label this as 1/3. That's what she sends. I'm sorry, that's not what she sends. This is what she has. Has 1/3. Are you with me? Okay. So she has 1/3. So I'm going to label in a different color just so it stands out. Yeah, I like the color code thing. Have you figured that one out? Okay. So then she sends 1/4 of the treats to school. So I'm going to break this up into fourths going in opposite direction. So I'm going to go fourths this way. Fourths going that way. So how many am I going to shade in fourths? How many? One. Only 1/4. It's only 1 over 4. So I'm going to just do this one because that's the place where they overlap. 1/4 to school. This is just how the math works. This is just how the math works. I prefer the math. But do you need to know how to do the rectangular model?
Yes.
You do, because it will help you with the word problems, because some of the word problems are tricky. There's a tricky word problem today. You can't just pick the numbers and go number, multiply. You have to read them. I know. Reading. Danger. You have to read them. Otherwise, you're going to get them wrong. You're going to really get them wrong. You have to read them. So, 1/4 of
1/3.
1/3, because she had 1/3 of the treats. She sent 1/4 of them. So 1/4 times 1/3.
1/12.
Which is, you multiply this, you multiply that.
1/12.
Multiply straight across. Now this morning, one of my students that I'm thankful that they listen to what I say and question. They said, but Miss Strickland, you said you don't mess with the denominators.
Exactly.
I said you don't add denominators. And you don't subtract denominators. I never said don't multiply.
See, that's the thing. You have to use
Well, when we get to dividing, we do what's called the reciprocal, and you flip it, and then you multiply. You flip it, and then you multiply. So, when we do dividing fractions, we end up multiplying. So, the only time that you do not mess with the denominator is adding or subtracting. Multiplying, straight across. Because adding, leave them alone. Are we adding them?
No.
No. Because if you look here, how many pieces do we have?
1, 2.
How many pieces do we have?
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12.
We don't have 3 or 4 anymore. If we were going to try to add these, we would have to find a common denominator. What would our common denominator be? What would our common denominator be?
12.
It would have been 12. Not that that had any relevance to this problem, but I'm not telling you to find a common denominator to do this, and I know that some of you, with your squirrel learning, picked up on common denominator and are going to start thinking that you have to do that. Multiply straight across. 1 times 1 is 1. 4 times 3. Someone is making a really weird noise. Stop it. 4 times 3 is 12. The only time you do not mess with them is adding and subtracting. You leave them alone unless you are finding a common denominator.
You don't have to stop looking back here because they think you're
And now I am starting, so you might want to stop talking. Thank you. So, with number 1, the example is done for you, and it says that half of 1/4 of a pan of brownies equals 1/8 of a pan of brownies. So all they did was they took, I'm going to show you how they did it. They took the rectangle and they've got 1/4 of a pan. So they took the pan, they divided it into fourths. They shaded 1/4 like so, because it's telling you 1/4. I'm just doing again what they did right here. No, I'm just explaining it because it's already done, and sometimes when the problem's already done, it's like, how on earth did they do that? Then they've got half of 1/4. So, oh wait. So here they've got it labeled that this right here is 1/4. This is just a problem set. You don't have to write stuff down unless you don't have a lot of room and you're wanting to write it again or whatever. You don't need paper. So, half of 1/4. So now they're taking this and in the opposite direction, they're dividing it into 1/2. So, then they're shading 1/2 to where it would overlap. 1/2. And then they're labeling it 1/2. This is half. This is 1/4. And then you get your answer because you've got 1, 2, 3, 4, 5, 6, 7, 8 is your denominator, and one of them is shaded in.
Oh, that's cool.
What?
Just 2 up in one hole.
Now if you take the math and you just do it the math way, 1/2 of 1/4, and you multiply, when you do it, you just multiply straight across. 1 times 1 is 1, 2 times 4 is 8. So they did the rectangular model to show it, and then the math is just multiply straight across. Yes? Yeah, it's exactly the same thing. I was just showing how they got that. Because it was already done, and I was showing how they got it. And then this is exactly the same thing that I was doing on the other problems. That was just setting it up. So 1/2 of 1/3 pan of brownies. So if I were doing a rectangular model, I would divide it into thirds, 3 sections. How many sections am I going to color in? 1. And then I'm going to label that as 1/3. And then I need to split it up again. How many?
1.
Half. Go across and label that 1/2, and I'm going to go this way. So my denominator is 6. How many pieces are colored in? 1.
I gotta write just how few the model.
Okay, but you also want to practice doing the math, because the models are okay, but the math is better.
1/2 times 1/3.
1/2 times 1/3. 1 times 1 is 1. 2 times 3 is 6. How you doing, Angel? You sure? Positive? You're awful quiet. You're positive. 1/4 of 1/3 a pan of brownies. Rectangle. How many sections?
4.
How many sections? How many sections are we going to do? 3. How many am I going to color in?
1.
Okay. How many am I going to go across left to right? 4. Because it says of 4. So 1, 2, 3, and 4. How many am I going to color in? 1. So this is 1/4. This was 1/3. I forgot to do that. And so I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 total pieces. 1 is colored in. 1/4 times 1/3. Go across. 1 times 1 is 1. 4 times 3 is 12.
The circle, do you have to warm up? So did I. So easy. Yes, that's exactly what I did. Yes. Wait, I got 8. I did something.
I don't know why. 1 times 1 is 1. 4 times 4 is 16.
I know, I got it. I got it.
I don't know why.
I got it.
3, 4,
The bar model makes it all easy. Well, 1/12 is
1 times 1 is 1. 2 times 6 is 4.
I got it right. I got it.
Very good. So, this is one of the times that you would actually need to be able to draw a rectangular model because it tells you to draw a rectangular fraction model. But you would also probably want to be able to back it up with math. Just because you would probably want to. So, draw rectangular fraction models of 3 times 1/4 and 1/3 times 1/4. Compare multiplying a number by 3 and by 1/3. So, what they're telling you to do is, well, that's nice, but that's going to be recorded. Hello, email. So, draw rectangular fraction models of 3 times 1/4. So 3 times 1/4. If I showed that as a rectangular model, 1/4. 1/4. So there's 1/4. There's 1/4. There's 1/4. And if I need to back that up with math, 3 times 1/4. Isn't there always a 1 underneath that whole number? Yes. Oh yeah, Miss Strickland told us that a really long time ago. Multiply across. 3 times 1. 3. 1 times 4. 4. 3. 4. Showed it. And then 1/3 times 1/4. So 1/3 of 1/4. So I'm going to do 1/4 again. So here's 1/4. Then this way I'm going to do breaking it into thirds. Then there's 1/3 of it. So what fraction do I get here? 1/12. So, 3 times 4 equals 12. So 1/3 times 1/4 equals 1/12. So if I were to compare the two, what do I see? What do I figure out?
That if you, I don't know if this is correct or not, but you're supposed to add your dividends. But you're supposed to add 3 4 plus 1 12, and when you notice that 12 and 4 go together, you take 4 all the way to 12, and then you can add it and get to 12.
Making it way harder than it is. If you multiply it by a whole number, what happens to my fraction?
It needs to be
It gets bigger. If I do a fraction of a fraction, it gets smaller. So 3 times 1/4 is greater than 1/3 of 1/4. Because I took my fraction and I multiplied it by a whole number. It made it bigger. Because here I had 1/4 and I multiplied it by 3. I made it bigger. I did 3 more. I did 3 of it. here I had a fourth, and then I broke it. I took, here, I had a fourth of a brownie, and then I shared it with 3 more people. Yeah, like we did with that pan of brownies, and we said, okay, now, here, you get a piece, and you get a piece, oh, get a piece. So yeah, I like you. I'm like, not like you. I said, like, you can get some, and then you get some, and then you get some. And so I took it, and I made it a whole lot smaller because I had to fraction it out. Because the more pieces you take off of it, the smaller it gets. This one, I multiplied it by bigger pieces. So instead of breaking it up, this one I made it bigger by multiplying it by a whole number. Yes?
Why did you, on the first one, why did you make it, like, why did you put that one?
Because I was showing that it was 1/4 that I multiplied by 3.
Okay.
That's all. So it was a fourth, and I went 1/4 times 3. And I went 1, 2, 3.
Do you write that thing that's at the very top too?
I would, yes, because it says compare. So I was comparing. I was showing that that is bigger than that.
Okay, thank you.
You are welcome.
Thank you for teaching.
Well, I try. Please just show that I teach you something on your test. Please.
Okay.
Goodness gracious.
Mr. Cool, this is a question. Do you just tell me your favorite one or do you come here? Don't say it to your face.
1/2 of Ila's workspace is covered in paper. 1/3 of the paper is covered in yellow sticky notes. What fraction of Ila's workspace is covered in yellow sticky notes? Draw a picture to support your answer.
Oh, wow. Wow. 1/6.
So this is her workspace. Half of it is covered in paper.
Oh, I did a third. I was
But I'm just doing what the paper says. What the problem says. Half of it. But it's multiplication. It's interchangeable.
So it's right still? It could be right as long as you got the right answer.
It's interchangeable. Half of it is covered. Sometimes it's interchangeable. You got to be careful though. Half of it is covered in paper. Stop it. 1/3 of the paper is covered in yellow sticky notes. 1, 2, 3. Now, I mean, I can continue this, but I'm trying to,
Say time.
because half of the workspace is covered in paper. Is this half covered in paper? No. So I'm doing dots to kind of continue it, but this half is covered in paper. This half isn't. So this is in thirds.
1/3.
So if I go, this is the half. So there's my half that's covered in paper. This is my third that's covered in sticky notes.
Oh, that will be 1/6.
1/3 of 1/2. So that. So we have 1, 2, 3, 4, 5, 6 total pieces. How many are shaded in?
1.
1. 1/3 of 1/2. Multiply across. 1 times 1 is 1. 3 times 2. 6. 1/2. No! Stop!
Oh my god.
1/6 is covered in sticky notes.
Wait, what'd you say? I didn't get it. What?
Nothing. I said nothing. I said nothing.
Did you say 1/6?
I did. I said 1/6. I exactly did. Yes, I did. Okay. I said nothing. You'll have to go back and watch the video to prove me a lie. Okay. Ha ha. So, Hop. So, a marching band is rehearsing in rectangular formation. That rarely ever happens.
Yes, it does.
They do swirlies and triangles and all kinds of things, but they rarely do a rectangular formation.
They will do a trapezoid.
1/5 of the marching band members play percussion instruments. That must be a very small band. Okay? 1/5 play percussion instruments. 1/2 of the percussionists play the snare drum. We're not pantomiming, please. Thank you.
This is easy.
What fraction of all the band members play the snare drum?
What's that snare drum?
Figure it out.
This is gonna be easy. My sister, when she went to school, had a teacher that just came for the money.
Oh, yeah.
1/5. 1, 2, 3, 4, 5. 1/5. 1/5. So 1/5 are in percussion. 1/2 plays snare. What fraction plays snare? 1/10. So 1/5 times 1/2 equals 1/10. We're on a roll. Okay, now, if on the last, what was that answer that you had a minute ago? 212. Okay, wait. If you worked ahead, I'm not messing with you because first period did the same thing. If you worked ahead and said 2/12 on number 5, I regret to inform you that you are incorrect.
You have to divide it, making it.
I have never taught you to divide fractions, so no, you are not dividing fractions.
No, but I mean just.
However, I want you to pay close attention to what the problem says. This is when it is extremely important to, one, not just pluck numbers out, and I'm not saying that's what you did because I did see you try to do a rectangular model. But not just pluck numbers out and go number, multiply. You have to be very careful and actually read the problem. Johnny. Hi. Okay. Marie, listen to the problem. Marie is designing a bedspread for her grandson's new bedroom. Is that relevant? No, that is not important information. 2/3 of the bedspread is covered in race cars. Okay, so I know that if I do a rectangular model, how many parts are there? 4. 2/3 of the bedspread is covered in race cars. And how many parts are there? 3. I'm doing one thing at a time. So 1, 2, 3. 2/3 of the bedspread is covered in race cars. So race cars. Race cars. The rest is striped. Striped. 1/4 of the stripes are red. If you did 1/4 of 2/3, you're doing 1/4 of race cars. Oh!
You gotta skip the whole way through and all the way to the stripe.
So it's really 1/4 of this part there. 1/4 of the stripes. Oh, you have to really pay attention to the problem. Do you remember? And you're going to go, no. There was at one point I said, knowing the math is great, but knowing how to do the picture, the diagram, the tape diagram, the model is very important because you're going to run into some of these wackadoo problems that you're going to have to really pay attention to what it says and draw it out, because it's going to be a fraction of a fraction, and you're going to have to be able to draw it out to figure it out, because you can't just pluck numbers out and multiply them together. Does it ring a bell?
No.
Yeah, I remember that.
If it doesn't ring a bell, then maybe you weren't really paying attention, because I remember saying it at least twice. So, race cars are not important to the problem, really. The race cars are there to help me realize that it's 2/3. So, it helped me realize that there were 2/3, but then the stripes are 1/3. 2/3 here, 1/3 here. So 1/3 of the bedspread is stripes. 1/4 of the stripes are red.
I see.
What? So 1/12 of the bedspread is covered in red stripes.
You said that you hated to say that Zach was wrong, but didn't Zach get 1/12? No, I got it.
He had 2/12 because he did 2/3 times 1/4, and he got 2/12. He did number, multiply. So because pulling the race cars, the stripes, without really paying attention to what the problem was saying.
Now I get
You
this.
have to pay attention to what the problem is saying.
At first I'm like, what is this?
This is talking about stripes. This is talking about race cars. And right here it says, the rest is stripes, which is 1/3. Just like yesterday, or on the study guide, it says the remaining. You remember that where it says she took the remaining to school? You had to listen to the word problem. You have to actually read it. You can't just pluck numbers out of there and add them or something. You have to read. You have to read. I know, crazy. Read word problems. There's words in there. You have to read them.